so we are now facing a global energy crisis, actually. Now, if you look at the annual global energy consumption, we are talking about something like 13 terawatts. And tera is a unit of 10 to the power 12. That means you have 12 zeros. So that sort of energy, you can see how massive it is. And around 80% of our energy now is coming from the burning of fossil fuels. And so obviously it will create a lot of problem because it will generate a lot of carbon dioxide emission. And this is something that we don't want. And actually by the year 2050, we need something like 27 to 33 terawatts. And so in order for us to maintain the existing demand of around 13 terawatts, you can imagine that by 2050, it's projected that we need an additional 14, at least another 14 terawatts energy gap. So this is again huge. Now, obviously, hydrogen is a very attractive option because it's not only just an energy source, but it's also an energy carrier. And what does it mean? What it means is that its potential role has a lot of similarities with that of electricity. Now, we found that actually both hydrogen and electricity can be produced by various different energy sources or different technologies. You can imagine that whether you are using hydrogen or electricity, you will not generate greenhouse gases. Now, people have been talking about blue hydrogen. Now, blue hydrogen is actually, they still produce the hydrogen from fossil fuel, but then they cut down on the CO2 emission with the use of something called carbon capture, utilization, and storage, CCUS, probably some of you have heard of. Now, of course, the best will be green hydrogen. Now, green hydrogen is used to describe those hydrogen that are produced from renewable electricity, from photovoltaics and so on. So obviously, this is the cleanest of all hydrogen, right? Because it's coming from renewable. Or so-called the blue hydrogen is from fossil fuel, but using carbon capture in order to help with the decarbonization. They will be talking about, like, as I mentioned, hydrogen is a very clean fuel, right? And actually, I can tell you 200 years ago, hydrogen was used to fuel the first internal combustion engine. And you can imagine for fuel cell technology, where you use hydrogen, as I just mentioned, the only thing that emits will be water. So fuel cell technology is also very attractive. So we'll hear from one of the speakers who is really an expert in electrochemical technology, in fuel cell, in electrolyzers. Now, there are still a lot of hurdles that we need to overcome in terms of the fuel cell technology, in terms of the electrolyzers. So we will hear a lot of that from our leading expert. Another thing is, of course, another clean way of producing hydrogen instead of just using electricity, electrolysis, is to use sunlight. Now, if we can have sunlight, solar power to split water. So electrolysis is splitting water to hydrogen and oxygen with electrochemical cell, right? Now, and if you have solar production or solar splitting of water to give hydrogen and oxygen, then we need to rely on photocatalysts. And how can we sort of come up with very efficient photocatalytic system and to mimic what nature has done, photosynthesis, and we call this artificial photosynthesis. And so there are still a lot of challenges that need to be met. And so we'd love to hear from these experts on what are the most up-to-date development and what are the challenges and hurdles that they need to overcome to make it happen.